Okay, full screen. So this is just going to be a little lecture. I'm going to use the absolute value function as my example to talk about some things. All right, and it's all about foundation, having a strong enough foundation to support future studies in this discipline. I think that's what we're about when we start with Algebra 1 and we try to build in high school students to get to calculus and understand it. Then it's all about strong foundations. And that means that there are certain things that have to be in place as you go up the ladder, certain understandings, right? And I remember a referee no, it was an announcer at big prize fights in the 70s and 80s. He'd get Mark and he'd go, "Are you ready to rumble?" Well, I'm ready to ramble. All right, so this is going to be a rambling discussion about what I think is important. And let me start with how we don't do things in math. And so most of our calculations fit a multiplication times a major operation and adding a constant. And what we decide to plug in, if you're performing a calculation, you generally put a number into a calculation and you get an answer out. And at the Algebra 1, students often have difficulty because they don't understand the concept of a variable. Believe me, I know there are students who have gone months without a clue as to what the letter X stands for, because I've seen it. And then when people figure that out, then the next thing that causes problem in the Algebra 1 level is order of operations. And please pardon my dear Aunt Sally, doesn't get the job done. I'm sorry. Math has evolved, harder and harder operations, and we tend to do the hardest operations first and then do the easiest operations last. So we don't read math from left to right. We look at it in terms of level of difficulty and so on and so forth. So the level of difficulty in this calculation is the function f of x. Before you multiply and add, you got to figure this out. And this is called the argument of the function. And we tend to put numbers in. But sometimes we can put another function in, like x minus 4. And sometimes those functions get more and more complicated. And at the calculus level, you look at this and you might study rates of change and, chain rule, things like that. But if you don't have a feeling for these functions, then you're working in the dark. And so our job is to make sure that you understand what e to the x is, its domain, its range. Right? Especially its range, because its range is going to determine the values for the sine function. And I don't have any confidence right now that all of those answers come from what I just asked. I know. I know that if I ask someone to graph that, I don't know if they could, without a calculator, get a feeling for what that looks like. If this is always positive, then you're not going to get the sine of 0 and so on and so forth. And what's the range of the sine function? You're still only going to get numbers between 1 and -1, and in this case, not even that. So there's a lot of things to work on to get here. And if those things aren't in place, then people drop out. And most people do. Right? So it's very important to not just do this, get that, but to actually have a feel for computations. Now, I'm not a big fan of transformations. You get a parent function and you shift it one direction and you make it increase faster or less quickly. And I feel like I'm always singing YMCA. Right? Transformations is really about seeing patterns. Right? You want to give students your chance to see patterns by working with a lot of functions and the actual computations with numbers. I think that's where understanding comes from. So we're going to have a little exercise here. And we're going to talk a little bit about the history of math, I think, and it's all conjecture on my part. What do I know? I mean, I was around in 1600, but I don't remember much about it. So let's just start with a number. Let's pick a number like 4. All right, let's do some operations. So I picked the number 4. Let's subtract 4. Now we're at 0. Let's take the absolute value of that. Well, the absolute value is 0, 0. Let's double it at 0. So maybe I should pick a different number. Let's start with 7. Let's start with 3. Okay, so 3 minus 4. Now we're at -1. And the absolute value of -1 is 1. So now we're here. And let's double that. So that's 1 times. Now we're at 2. And let's add, whatever I said, 5. Now we're at 7. There we go. All right, so now you can see what I did. And you have complete understanding of all the processes and, Oh, yeah, you're right. Didn't help you too much to know where you are without knowing anything here. You know, unless you saw the video and heard me say things, I think you're lost. I think you walked into the woods and you're lost. All right, so go back to where we started from. I think you're still lost. All right, so what happened in the 1600s? Good old Rene Descartes, who's parked in the back there, came up with this way of visualizing things. So now let's do it again. Let's pick the number 4. Okay, let's do x minus 4. Well, I changed to say, let's let x equal 7 and then subtract 4. See, this is going to be a ramble. But the bottom line is, if I know what that looks like and study it, little awkward transition in where I was 30 seconds ago. But then you can see that 4 gets you 0. And then if you know, some other random number and you subtract 4, well, then you can keep track of things. Keep track of things. You can see the operations unfold. Okay, so I would hope that if you study algebra and you've been at it for a little while, you would say that's the equation of a line. And we then hopefully learn that we're over 1 and up 1, and we have a building of foundation. So what happens when I slap it now with the absolute value? Oh, all those negatives become positive. And now we study math. If you see that V-shaped graph, you might know one of the operations and where it came from. And you might even know the most important value. And then if I double things, well, then we're talking about, oh, this is a Y value. And if I double it, it's now there. YMCA, sorry. Yeah, so now we're looking at this. Going up faster. We're already talking about rates of change, which happens to be something that happens to be studied at the calculus level, except we look at rates of change for all the functions. Well, good luck figuring out the rate of change of ln of x if you can't even graph it. So, and then we do what? We add 5. All right, so now I'm going to add 5. 1, 2, 3, 4, 5, and I'm there. So let's pick a number randomly. Okay, and let's look at the graph of 2 absolute value of x minus 4 plus 5. Okay, well, 4 gets you 5. So I guess that's the 4. We go up 1, 2, 3, 4, 5. So once we pick a number, everything else is about the differentials. It's about seeing movement from 4. And we take what after that? Absolute value. So I know I'm going to get a V-shaped graph at 4, 5. The question is, how do I make it go through here? Well, I guess we got to double things. And so now I'm at 4, 5. So I got to double that Y value, which means that, well, I got to pick a number, right? And I don't know what number I want to pick here. Maybe I picked 7 before. I said this would be a bit of a ramble. So now I've got the number 7. I'm plugging it in and I'm doing the math. And if I do, I get the absolute value of 3 times 2, 6 plus 5 is 11. And hopefully you've studied this enough at this point that you see that and you go, oh, I know to do that because I've done it enough. And I know I got to get from 5 to 11. I know I got to go up 6 units. But from 4 to 7 is an absolute value of 3 for change. And then we can see the 2. Okay, so I guess what I'm saying is math evolved. And thanks to Rene, we have pictures. And if you can picture something, you own it, I think. Okay, so outcomes, inputs, outcomes. All right, and we do that all across the board in education. Historians see the outcome of authoritarianism. So what do? They retrace their steps to see, well, where did that start in our past? Therapists, somebody comes into you're a therapist, somebody comes in and starts talking about their dad and da 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 da. You might retrace your steps and say, well, where did you have trouble with your father? I mean, what, so on and so forth. These are endless. Somebody's sitting under an apple tree. Whoop, sorry, projector, right? And they see this object fall and they see other apples fall and they don't see an apple going the other direction. Somebody starts thinking about it and then oh, well, that's the same thing as throwing it up and catching it. So somebody threw that apple up and, well, maybe not, probably grew off the branch, but seeing it fall, analyzing it, acceleration, velocity, position, so on and so forth. So you got to start somewhere, think about things or work with something, and then hopefully learn something about the process. And if you want to continue up through calculus, well, you better have a good foundation. 30 years ago, as high school teachers, we would hear, boy, from the colleges that, you know, they're not really faring too well with the upper level classes, and it's all about weak foundations. And now high school teachers are going, God almighty, but, you know, with COVID and internet and everything else, students aren't thinking about these problems enough. And, you know, people come in and can't add and subtract fractions, multiply and divide. It's pretty hard to teach the high school level, so on and so forth. So we need to change that trend. All right, I said this would be a ramble. It's a ramble. All right, so let's look at this again from the standpoint of I'm not sure. Maybe I've said what I wanted to say, but certainly René Descartes, right, with that X and Y axis, input, output. We got to be thankful because now we have pictures that can help us unravel things and study things, all kinds of different calculations. So I'll do three, let me see, but maybe I'll do three absolute value problems right now, just for those students who still have not figured out how to write these as piecewise functions, so on and so forth. Solving. So let's just take a random -3, x -4 plus 7. Let's do that. Let's call that our function. Okay, so absolute value always kicks out positive numbers, but what are you doing to those positive numbers? Multiplying by a negative. So we have a tendency to be going down. So we have that. Okay, where does it hinge? Remember, x -4 is a linear function. Slap the absolute value, that's where the hinge is. So 4 is the important input. And we can see that 4 minus 4 is 0, and 0 is a minimum. Absolute value just kicks out positive numbers. It talks about the magnitude of the number, whether it's positive or negative. The magnitude of positive and negative 4 is 4. It's also described as distance from 0 on a number line. And there's a minimum distance you can travel. But if you put a minus sign in front of a minimum, you get a maximum. So you plug 4 in and you get a 7. And I think you really got to plug 4 in and see how it works versus saying, oh, we're shifting a graph up 7 units. Just put the number 4 in and you see 7. Output. Okay, and yes, we usually put it in parentheses. Now we need one more number. I mean, I got to know how. So let's put a number in. Let's say it passes through 9 something. 9, how about -4? Okay, well, 4 to 9 is absolute value of 5. All right, so, oh, I'm doing this one. Okay, so I've already given you a function. So let's put 0 in because I always like the y-intercept. 0 is in reference to where it hinges to the left. And it's not hard. 0 minus 4, -4. The magnitude of that is 4, -12 plus 7, -5. And that's going to get you 2 points on next test. If you can simply show that, we're moving in the right direction. Now, how do we write it as a piecewise? Well, we get Alfred Hitchcock on the board. That's a very bad Alfred Hitchcock. Yeah, close enough. Well, if you follow a graph from left to right, then we're really moving in the 0, 1, 2, 3, 4, 5. It's easier to understand numbers that way. We count forward, smaller to bigger. So that's our frame of reference. And you need a frame of reference, a starting point to understand a calculation. So I think my finger's going up. And I think it's passing through 4, 7. And if I erase this, I think I have the equation of a line. And I think it's going up. And it includes that point, 7. But then, that's only true for x's to the left of 4. To the right of 4, I think I'm going down. And I do have 4. So that's those are the pieces of this absolute value. And that's the last time you're going to see me do it. Right? It's on you. Been doing it since what, January 10th, somewhere in there we started. All right, so that's going to get you one of those on the next test. And then we can start asking questions like, oh, when does this function equal, let's see, something nice. Let's go -8. How about we do -11? Okay. All right. So let's come back to that. All right. So in this class, we subtract 7, we divide by -3, and now we're at this junction. And I know a magnitude of 6 can come from either +6 or -6. So therefore I have 2 equations, one +6, one -6. The other way to look at it is, I know I'm centered at 4 and I'm moving 6 in this direction, 10, and I must be moving 6 in this direction, 10. But if I did it from the x minus 4 equals -6, x minus 4 equals +6, I should be able to get those same answers. Add 4, -2, add 4, 10. One was conceptualizing what's going on, and the other is working the mechanics. And I fall on the side of, I want you to see what's going on conceptually at all levels of high school mathematics. And that's an evolving process. I mean, I'm seeing things after doing this for 45 or 50 years that I didn't see last year. That doesn't stop. I don't expect it to stop. So now we have found our answers. So being able to solve one of these and getting 2 answers is going to get you another check. All right. And when I'm asking about 130 things. Okay, what comes next? Let's talk about when we're less than -11. Well, in order to answer that, you got to have these numbers. Well, you got to be able to figure out how to get that quickly and easily. And then there's 2 ways to get it. Plug numbers in, see what works. Will I get, with 10 and -10, something less than -11? No. I'm going to get these numbers. So therefore, no, this number doesn't work. This number doesn't work. Okay, so what does work? Well, these are intervals. Interval A, interval B, and interval C. Let's put a number bigger than 10 in. Let's put 1,000,000 in. -3 times 1,000,000 plus 7. Right? I really think that's not affecting this. Okay, so that's -3 million. Is -3 million less than -11? I think so. Bigger magnitude, but on a number line, certainly below it. So yes, true. All right, let's put 0 in. 0's between these numbers. Let's see if interval B works. Notice I'm using the word interval. So let's put a 0 in. 0 gets me 4, right? Magnitude of -4. I'm sorry, put a 0 in. -4, the magnitude of -4 is 4. And I get -12 plus 7, which is -5. -5, less than -11. I don't think so. I think that's false. And then we can look at about negative million. Well, negative million is going to get the same thing as the absolute value of a million we did before, so that's true. I'll even write it out. Okay, so we have some intervals that work. Why don't we create something called interval notation? Negative infinity to negative 2. Negative 2 doesn't work. Union 10 to infinity. It does work. Infinity. Keep going. Keep going. No, keep going. Keep going. Keep going. That's a discussion of range. Keep going. All right. So, next step, could you have seen it graphically in your mind's eye? Could you have seen negative absolute value? Could you have pictured that? And where are the y values? That was what this function, that this discussion was basically about. We get a starting point, and then everything is all about the y values. And these y values are below a height of negative 11. They're below it. And these y values aren't. So could you have pictured that? Could you have pictured negative infinity to negative 2, union 10 to infinity? Well, that's your challenge. That's your challenge. And I hope that you're making some gains there. And these videos are trying to help you make some gains here. Takes thinking and so on and so forth. So if I wanted or equal to, just the last thing from a mechanical standpoint, the parentheses becomes a bracket, because now the numbers negative 10 and negative 2, 10 and negative 2 do work. All right, so what have I forgotten to say? As soon as I click the video off, I'll know there's a half a dozen things that could have also been said. But we're going to go to daily quizzes now, where the problems I'm seeing, which are usually blanks on a test, give you an opportunity to maybe fill in those blanks in the last 3 weeks of study. And so I'll do 3 problems and another 3 problems on a different type of function. And I'll know if you gave it some thought, because I'm going to give you a quiz the next day. I'll pick one of the 3 out and one of the other 3 out. And then I'll just give it to you and say, you got 4 minutes, do these 2 problems. And I'll keep track of who's working and who isn't. All right, so that's what's coming your way. Toodaloo.